I think you'll agree that's a truly amazing site. But how many people in the room know that SolidWorks played its own small part in making that happen? To tell the engineering story behind the headlines, I'd like to welcome on stage Art Thompson and John Wells from Sage Aviation to let you know how we got this thing off the ground. So, before we talk about the Red Bull Stratus project, are there any other projects that we might have heard about that you were involved in, Art?
Well, in the late 70s, with a group of about 14 engineers at Northrop Corporation, we conceptualized the idea and presented and designed the stealth bomber. Did a series of programs with low observable aircraft. And with one of our sister companies that we have is A to Z Effects. We did the Mini Coopers, which so many of you probably have seen, the canned cars, built over 700 vehicles for Red Bull. And then movie projects such as the Batmobile and Air Force One, Contact, so different things like that.
Very, very varied projects. But the Red Bull project, first question has got to be, who thought of this idea? Where did it start?
Yeah, the original conception goes back to an amazing man. Joe Kickinger worked with the Air Force in the late 50s and 60s. The president wanted to see, could man survive at altitude? It was pre-Apollo, pre-Gemini, it was before the space program. And they wanted to know, could man go to these levels? And so the Air Force set off to put people into high-altitude scientific balloons to get them up there. Joe went up in 1960 to an altitude of 102,800 feet, where he stepped off and became the first person to free fall from that altitude. That record's held for 52 years, and it really was something that was the pinnacle of what every parachutist wanted to try and do again. And so Felix, who's a good friend of mine, knowing my background in aerospace, called me one day and said, "Art, you familiar with Joe Kickinger?" And I said, "Yes, I am." He says, if you were going to break Joe's record, how would you go about doing it? I said, "Well, let me think about this a little bit, and I'll give you a call tomorrow." So I called up a couple friends. One of mine, Rick Searfoss, who was the shuttle commander for Columbia and Endeavor. And Rick was also the chief judge for X Prize. It was before Scale Composites had won the first phase of the X Prize with Spaceship One. And a dear friend of mine, Eric Purdom. And we sat down and started conceiving the design and idea of how we would go about doing it, including the possibility of a rocket plane. And eventually jumped on a plane, flew over to Austria, and presented to Felix and Red Bull some concepts. But it had to be a flight test program. It had to be a serious scientific endeavor.
So to sum up your pitch to Felix, you basically said, "Felix, we're going to put you in a can, attach a big helium balloon to it, lift you up to the edge of space, you're going to jump out, break the sound barrier, pull a ripcord, land safely."
Something like that, yeah.
I don't know about Felix, but I'd have taken quite a bit of convincing to actually do that.
Yeah, it had been a dream of his since the time he was a little kid. You know, growing up, looking at the astronauts and the Apollo program and all that, and so it was something that was truly in his heart. So it took a little bit of convincing, but you know, I think as we got into some of the more safety issues, he started realizing how technical and what kind of level of problem it was, and why it had to be a true flight test program.
So John, you're the designer. You know, Art's the ideas man. You want to create his ideas into reality. So what did you think about the project when he explained it all to you?
Well, I first came on the project in 2008. It was going from napkin sketches and concept to actual physical design and layout of all the components. And I was told it'd be a 6-month program. It'd be real fun to start. And 5 years later, over 15,000 hours of my life put into the program. We designed the components and built a flight test program to make it a reality.
I mean, one of the things with the flight test program is it's all about safety. But surely jumping from the edge of space is inherently unsafe. I mean, how do you make it safe?
You have to really think about the entire test program. I mean, one of the things was really bringing together a group of brilliant designers and engineers, friends of mine who I've worked with on a number of other aerospace projects that bring a lot of credibility in mind to what we're trying to create. That's really the important thing.
Okay. Now, we saw on the video the pressure suit that Felix was wearing. That looked like a pretty sophisticated piece of kit. I don't think that's in my local Walmart. Where did you find that?
Well, the inspiration of the pressure suit, the spacesuit, is really from a friend of mine, Bill Weaver, back in '67. He was a test pilot for SR-71s. Bill was forcibly ejected out of a SR-71, a Blackbird, one of the fastest aircraft, that came apart around him, and he was wearing a David Clark suit, and he survived an ejection out of an aircraft at Mach 3.18. So he's going over 2,100 miles an hour. Hearing that story, and knowing Bill, I said, that's probably the suit we need. So David Clark Company has a rich history of creating the pressure suits for the Space Shuttle crew escape suits, the orange suits you see, as well as the U-2 suits for the high-altitude spy planes and reconnaissance aircraft. And so David Clark, who has been having people come to them for over 40 years or 52 years, with people trying to buy these suits or use these suits, they've been telling people no on a rate of about 4 times a week. So I showed up on their door and said, I'm interested in getting some spacesuits. And that took a lot of convincing to get them to understand that we're truly an aerospace group and technical team, that we had the confidence to be able to really assure that we were going to take this the next step. There's been a number of people who have died trying to break Joe's record, and so there's a big concern over liability. So being the first company to be able to purchase a spacesuit is a pretty significant thing.
I mean, John, your job was to design the capsule that Felix went up in. What was technically the most challenging part of that whole process?
Most challenging part of the process is really putting a pilot in a position I would never put myself, making sure that everything's tested out right, all the design procedures, making sure everything is done and followed through to guarantee his safety. And the life support system on it is second to none.
I mean, how many people were actually involved in the whole project from on the design side?
Well, the Sage Tishrak team, as far as engineering and staff, there's Riddell, which was communications. There's Flightline Films for the camera works, camera systems. We had a team of about probably 25 medical doctors. The direct involvement, probably about 10 doctors on the physiological side. Engineering staff was probably in total, including the launch crew and everything, about 50 people total. But the core team at Sage Tishar that did most of the design, fab, engineering, was probably only about 12 people.
That's actually quite a small group.
Yeah, it's very small, but the nice thing is you're very efficient.
So in the whole program, I mean, Felix came up with the idea, but was there any point in the program that you wondered if Felix could actually do it? I mean, were there times you had doubts?
There was a big concern. What we did in the early part, in the conceptual phase, is we built much like all of you have done, you start with a napkin sketch, a concept, an idea, builds into some development models. We built a plywood mock-up of the capsule that was an ergonomics model, just to kind of think through the process. That was drawn out in CAD and machined on our 5-axis mill. We built the ergonomics model, put Felix in, snuck a U2 suit out the back door of one of the other facilities. Don't let anybody know. Okay? So to get Felix in and put him in the suit to see, because there's a concern right off the bat with pilots is that when you put somebody in a spacesuit, there's this feeling of claustrophobia being closed in. So Felix shows up thinking that he's looking and testing us for, okay, what do you guys have in mind? You know, what are we looking at here? And our group is on the other side of the room going, okay, now we're going to see if he can handle being in the suit. So we stuck him in the suit, put him in the ergonomic model, had him sitting there. We pressurized him, so he's all inflated. And then we left him there. We walked away. Mike Todd, our life support engineer, leans over. He says, "You know, this may just work." So after deflating the suit and letting him out, and Felix was a natural. He took to it very quickly. You know, what was disturbing along the process, it was at one point when we went for doing some of our testing, Felix had a breakdown where he got claustrophobic, and so we ended up having to call in groups. And Felix asked me at that point, it's like, well, what does the Air Force do if a pilot gets claustrophobic or he has a problem? How do they cure him of that? So they usually get rid of him and bring in the next guy. But Felix overcame his fears, and we eventually worked through the process and got him to altitude. And you got to admit, I mean, for somebody to step off that kind of an altitude, it's
pretty intense.
A lot,
yeah.
pretty intense.
I mean, John, SolidWorks takes pride in listening to its customers and developing solutions for them. Now, Felix was your customer, so did he actually involve himself in the design process? How did things change?
Felix is his line of work. He's a very meticulous customer. He really likes to be able to walk up and see multiple options that are all possible solution, which on our case brought up 3 to 4 times the amount of work and having to develop multiple options for every possible problem that we can come across. So Felix would actually come in, we'd present him with options A, B, C, and he'd decide which one would work best for him. And then from there we'd move on to the next problem, the next set of solutions, and progress forward with the program.
I mean, Art, you talked about this as being a flight test program. I mean, what did NASA think about this?
NASA at first, when we first came to NASA and talked about the ideas, were incredibly excited. You know, the technical team looked at it and said, this is what we lived to do in the 60s and 70s. It represented everything that the space program was. So they were really excited about it. But then when you start getting the attorneys involved and the bureaucracy and everything else, and they start thinking liability, and I don't know what happens if something goes wrong and we're involved and our name's attached. And so because of that, there was a big resistance, which was okay in the long run, because what we ended up doing at Sage Tissue Aerospace, we ended up developing and creating a lot of the things ourselves, or figuring out what the solutions were on our own. By the time we finished, NASA, of course, came back around and said, you know, but by then we were already past that point, so it's okay. Well, we can have you participate and watch the programs and stuff. And so it was really a challenge to overcome a lot of the bureaucracy and issues.
So the whole project was as much a feat of engineering as defeating the evil bureaucracy.
Yeah, definitely overcoming bureaucracy and trying to keep it as simple as possible.
I mean, one of the questions I've always thought about, if I was to go up there, that I'd never go up there, but what if something went wrong? I mean, with a capsule and a spacesuit, what if both things fail? What would happen to it?
Well, at altitude, with atmospheric pressure, when you get up to about 60,000 feet, 61,000 feet, it's something called the Armstrong line. Not to be confused with Neil Armstrong, but Dr. Armstrong had discovered that at a certain altitude, there's enough atmospheric pressure to hold the gases in your blood in suspension. Once you get beyond that, the oxygen and all the gases that are in your bloodstream start to escape. They want to come out of suspension. And so if you had a failure of the pressure suit, if you had a failure of the capsule itself at altitude, above 60,000 feet. It would be like taking a box of Pop Rocks and sticking it in your mouth. It would start to fuzz, fizzle, and bubble in your mouth. And then it would start to ooze from your eyes, your ears, your nose. Your body would inflate to be about twice the size. And so it's a very painful process.
Good job it didn't happen. The Red Bull project was quite a long, drawn-out project, very high pressure. I mean, what did you do to relieve the pressure for the team?
Well, people who know me know I like to do a lot of crazy things and think outside the box. Just a few. Get involved in people come with projects and ideas that seem a little bit nuts, and I usually say, yeah, we can do that. So in the process of doing Red Bull Stratos, while we were preparing for Man Flight 1 to go to 71,000 feet, Pima Air and Space Museum had come to me and said that they wanted to build a paper airplane. So we ended up building the world's largest paper airplane. It was 45.5 feet long, had a wingspan of 24 feet, all paper. We launched it from a Sikorsky S-58T helicopter of an altitude of about 1,400 feet. It flew just short of a mile, got up to about 98 miles an hour in free fall in flight. Actually was removing parts of the flight surfaces. And definitely set some new records there. But that was 6 days after Man Flight 1.
So not only did he ask you to actually make this capsule, John, he also gave you a nice little side project.
Yeah, a nice weekend project, something that would motivate kids. So possibilities that they could do large projects in the future.
Next generation.
It was a fun weekend gig after doing a very intense Man Flight 1.
So we all, like I say, we saw what happened up until the point that Felix jumped off the capsule. Let's have a quick look at what happened after that.